Hey for afraid, we are back at it again this week with guess what? Yes, fractions. So last week we learned how to identify fractions using fraction models, or in our case we use fraction strips. This week we'll be learning that fractions with different numerators and denominators may be equal using fraction models and equations to create an equivalent fraction. So as always, I like to review before we jump right into anything new, but I also like to get you guys prepared. So this week's lesson, you'll just need a pencil and a piece of paper to take notes. Let's review. So a fraction is a number that is either part of a whole or a part of a group. Come on, say it with me. A fraction is the number that is either part of a whole or a part of a group. And with a fraction, you have your numerator, which is above the fraction line, which is the part, and you have your denominator below the fraction line, which is the whole. In last week's lesson, we learned what an equivalent fraction was. And an equivalent fraction is two fractions that equal the same amount, or two fractions that take up the same amount of space. Still a quick review from one of our problems we had last week. It says, Tim and Carol both have the same size can of soda. Tim drank 1/3 of his soda. Carol drank 2/6 of her soda. Did they drink the same amount of soda? So we know that Tim drank 1/3 of his soda and Carol drank 2/6 of her soda. As you can see right here, I have the fraction 1/3 and I also have the fraction 1/6. Underneath the fraction, I have the fraction model of showing you 1/3 and 2/6. Well, not exactly showing you 1/3 and 2/6 yet because I haven't shaded anything yet. So that's where I want you guys to help me now and take the time to shade in. Let's shade in 1/3 of this fraction model. Now I'm going to also shade in 2/6 of this fraction model. 1, 2. Now, as you can take a look at the model, you can see that 1/3 and 2/6 both take up the same amount of space in both of their fraction models. So, like last week we learned that 1/3 and 2/6 are equivalent fractions, which takes us right into our lesson of this week, that equivalent fractions may have different numerators and denominators. Let's create equivalent fractions using fraction models with different numerators and or denominators. So, for example, let's use 1/4 and 2/8. Now, although 1/4 and 2/8 are different numbers, I'm going to show you how 1/4 and 2/8 are equivalent fractions. Right here under this 1/4, I am going to draw a fraction model of 1/4. And I'm going to shade in 1/4 of this fraction model. And right here, I'm going to draw our same 1/4 fraction model. Right here, we have the same fraction model as the 1/4 fraction model, but now this time we're going to break each of the section into 2. So we just went from 4 sections to 1, 2, 3, 4, 5, 6, 7, 8 to 8 sections. Now I'm going to shade in 2/8. And as you can see from me shading in 2/8, that 1/4 and 2/8 take up the same amount of space. So these two fractions are equivalent. So these two fractions are equal. Now we're going to work through the same problem, another way for a better understanding. So again, we started off with 1/4 and 2/8. And we already know that 1/4 and 2/8 are equivalent to one another. So I'll just keep that right there. Now, this time I'm going to start with 1 whole. And I'm going to break our 1 whole down into fourths. And now our 1 whole is broken down into fourths. I'm going to shade in one section of this 1 whole to represent 1/4. Now we have 1/4. Let's see what would happen if we split our fourths into eighths. Remember, right now, this is broken down into fourths. So let's split it up into eighths. And I'm going to use a different color marker. And now I'm just going to split our fourths up. And now we just went from 1/4 to 2/8. We can see that the fraction of the whole stayed the same, even though now 2 parts are shaded versus 1 part being shaded. Remember that when our denominators are larger, there are more parts of a whole, and each individual part is smaller, which basically means that the larger your denominator is, the more pieces you'll have in your whole. So now the numbers in our fraction now read 2/8 instead of 1/4. We can also show that 1/4 and 2/8 are equivalent by using an equation. We're about to create our own equation. So we're going to start with, of course, 1/4 again. And I'm going to also start with the model. Of 1/4. Now I'm going to multiply each part of our fraction, the numerator and the denominator, by 2. So I'm going to do 2 times 1 equals 2, and 4 times 2 equals 8. We multiply each of the parts by 2, showing that 1/4 and 2/8 are equal again. And this is what literally, wrong color. This is what literally happened to our visual model. Going from 1/4 to 2/8 once again. Let's try working with a completely different problem using an equation. And this time we are going to work with 1/3. So 1/3, I'm going to draw a circle, and I'm going to split. I'm going to color this portion right here to represent 1/3. Let's create our equivalent fraction by multiplying 1/3 by 3. Remember that whatever you multiply your numerator by, you need to also multiply your denominator by. So I'm just going to take a different color to show multiplying the numerator by 3, multiplying the denominator by 3 as well. Now, 1 times 3 equals 3. And 3 times 3 equals 9. And there you have it. 1/3 is equivalent to 3/9. Taking a look at our visual model, we went from thirds to ninths. So we're going to break each of the 3 pieces up into 3 pieces. And there you have it. Your 1/3 and your 3/9 each take up the same amount of space, because all in all, that's what equivalent fractions are. Whether the numerators or the numerators or the denominators are the same, equivalent fractions take up the same amount of space. See that our section went from one section being shaded to 3 sections being shaded, but even though our section went from one section being shaded to 3 sections being shaded, they still take up the same amount of space. In this lesson, you have learned how to create equivalent fraction using visual models and equations. See you all next time.